Hi, I'm Florian, and on behalf of my co-authors Verena, Albrecht, and Tonja, I would like to introduce BrailleBuddy, a tangible user interface to support children with visual impairment in learning Braille. Braille is a tactile font that is used by people with visual impairment and blindness worldwide. On the bottom, we show BrailleBuddy, a device that motivates children to explore and learn Braille. There are various resources available to support children in learning Braille. Examples are tangible books. In the picture, we show such a book with stuffed animals and other tangible objects placed on the pages next to the object's name written in Braille and printed text. There is also research on using tangible user interfaces for Braille learning to combine the natural form of interaction provided by real-world objects with the possibilities of technology. In the picture, we show Braille blocks. Here, users can form enlarged Braille characters by placing red cylinders into a green box. A camera setup recognizes the placed characters and provides feedback to a sighted parent or teacher. We now strive to combine the advantages of different Braille learning resources. We want to create a digital and tangible device offering interaction and feedback to the user. Further, we want to reduce the need for a complex setup or supervision by a sighted teacher or parent, so that children can use the device in a self-directed manner. Using the device should be fun and motivate children to use it frequently and engage with Braille. We created BrailleBuddy in 6 design iterations involving Braille experts, students, and teachers. First, we designed a concept based on related work, showing an enlarged Braille character either in a fixed layout or as a swing cell with audio feedback. We then created a clay prototype of that concept to discuss our work with experts with visual impairment. Based on their feedback, we developed a new concept using standard-sized Braille characters on cards that can be placed on top of a box. We further refined and improved our design using a cardboard prototype that supported the placement of one card. Then, we constructed a functional prototype already resembling our final device and allowing for placing multiple cards. Finally, we discussed a fully functional prototype closely resembling BrailleBuddy. From our design process, we derived crucial points that multiple stakeholders highlighted. First, we should focus on standard-sized Braille characters, as enlarged characters are only used briefly. Similarly, the device should focus on spelling words instead of reading or writing single letters. Lastly, the cards can be placed on top, should be wide enough to place 2 Braille characters for uppercase letters or numbers, but also as narrow as possible not to hinder the perception of the word as a whole. The cards also should include a beveled corner to indicate the correct orientation. Focusing on these points, we built BrailleBuddy. All resources, including models and code, are available on GitHub. BrailleBuddy is a wooden box with RFID readers and a speaker inside. It allows children to place cards on top and provides audio feedback for various games. BrailleBuddy contains one large recess for cards that control which game the user wants to play. Next to it, there are 7 narrow recessed areas for cards containing 1 Braille character each. By placing these cards, the user can spell words and solve the game they are playing. Below each card, BrailleBuddy contains a button. Upon pressing this button, BrailleBuddy repeats the audio feedback from placing the respective card. The cards that can be placed on BrailleBuddy are 3D printed and then painted to improve their feel. We printed 47 larger cards that the user can place to select the game they want to play. 2 of these cards are only labeled with Braille. The first card starts the game Word Scramble, where BrailleBuddy gives a set of random letters, and the child has to find a word by ordering them correctly. The second card starts the game Word Riddle. Here, BrailleBuddy selects a random word and the child has to guess the word by placing letters on top of BrailleBuddy. BrailleBuddy then provides feedback if and how often the letter is contained, similar to the game Hangman. The third type of larger card starts the game word copy. Here, BrailleBuddy asks the user to spell the word depicted on the card. We printed 12 cards with 3D figurine of an object and the object's name written in Braille beneath it. We also created 33 cards that contain a 2D relief image instead of the figurine. These cards also start the game word copy. To solve these games, we also printed 99 letter cards. Each letter of the alphabet is contained once in upper and lower case. We added duplicate cards for frequently used letters. Each letter card is labeled with the letter in printed, elevated text and with the Braille representation. Here we show the card for the letter M. Now we show a video of a user playing a game of word copy.
Can you spell this word, letter by letter? Here.
The user now needs to select the correct letter card and place it on BrailleBuddy, which reads the letter and indicates if it is correct.
H. A.
Incorrect letters are indicated as well and can be corrected by replacing the letter card.
S. R.
After completing the game, BrailleBuddy makes a finishing sound.
E.
We conducted a user study at a special education school for children with visual impairment and had 11 participants from grades 1, 2 and 3. During the study duration of 30 minutes, every child played at least one game of word copy, followed by the other games if time allowed. The children were selected by their teacher and had varying levels of Braille knowledge. One teacher was always present and we collected qualitative feedback from the students and the teacher. Throughout the study, our participants played 14 rounds of the first game, word copy, where they had to spell a given word. 13 rounds of the other two games were played. We present our results on how children could find the correct letter card and on their interaction with BrailleBuddy. 7 of the 11 children could scan the letter cards independently. However, 4 received some verbal hints if they skipped over a card multiple times. A clear strategy of scanning the cards and keeping the area with the letter cards tidy proved crucial factors for quickly selecting the letters. 7 out of 11 children could interact with BrailleBuddy immediately without any support. Further, 9 children vividly expressed their enjoyment during the study. When asked towards the end of the study, all but one child answered that they would like to play with BrailleBuddy again. Our results show that BrailleBuddy is enjoyable for most children. It motivates them to engage with Braille and extend their reading and spelling skills. BrailleBuddy is also usable in a self-directed manner without supervision and therefore can be used by children in breaks or at home. To conclude, BrailleBuddy highlights how we can design tangible user interfaces for Braille learning. Such devices can complement traditional teaching methods in Braille education and provide additional encounters with Braille for children with visual impairment. As mentioned, all models and the code are available on GitHub for you to use and extend. If you have any questions, please contact me via email.